Welcome to section 5.3, congruent angles associated with parallel lines. The objective of this lesson is to apply the parallel postulate, identify pairs of angles formed by a transversal cutting a parallel line, and apply 6 theorems about parallel lines. For our homework, it's going to be on page 229 to 233, 2, 7 through 10, 15, 22 to 23, and 26 to 27. So we start off with a postulate and a theorem. Our postulate reads, through a point not on a line, there is exactly one parallel to the given line. Which means when we do an auxiliary, we can purposely, intentionally, draw a line such that it's parallel to our given line. That's how that's going to work. This is going to be applying to our auxiliary. Now, our next theorem. If two parallel lines are cut by a transversal, then any pair of angles formed are either congruent or supplementary. So no matter what, when we have parallel lines cut by a transversal, we're only going to have two options. They're either going to be congruent to each other, or they're going to be supplements of one another. Okay, so we're going to start off with 3 theorems that kind of go together. If two parallel lines are cut by a transversal, each pair of corresponding angles are congruent. So let's say that for this first theorem, we already know that we have parallel lines, and they're going to be noted by those little arrows formed on them. If we know that those lines are parallel, then we can say the corresponding angles. Angle 1 and angle 5 are congruent. Or we can match up angle 2 with angle 6. We can match up angle 3 with angle 7, or we can match up angle 4 with angle 8. So that's our first one. Parallel lines yield corresponding angles congruent. Our second one. If two parallel lines are cut by a transversal, each pair of alternate exterior angles are congruent. So again, we got those parallel lines. Once you know that those lines are parallel, those alternate exterior angles, angle 1 is congruent to angle 8, or angle 2 is congruent to angle 7. Our last one. If two parallel lines are cut by a transversal, each pair of alternate interior angles are congruent. So again, we got our parallel lines, those alternate interior angles. Angle 3 is congruent to angle 6, and angle 4 is congruent to angle 5. Now, our next 2 theorems that match together. If two parallel lines are cut by a transversal, each pair of exterior angles on the same side of a transversal are supplementary. So like before, let's say that we start off knowing that we have parallel lines. We have those little arrows on them. What our first theorem says is that angle 1 is going to be supplementary to angle 7, or angle 2 is going to be supplementary to angle 8. What do you think our shorthand for this is going to be? Parallel lines yield same side, exterior, supplementary. Our next one. If two parallel lines are cut by a transversal, each pair of interior angles on the same side of the transversal are supplementary. So again, once we know our parallel lines, I can say angle 3 is supplementary to angle 5, and angle 4 is supplementary to angle 6. My shorthand for this is going to be parallel lines yield same side, interior, supplementary. And here's our last 2 theorems. If 2 lines are parallel to a third line, then they're parallel to each other. It's kind of like the transitive property of parallel lines, and you can call it such. So let's label these parallel lines here. Let's label them A, B, and C. So let's say we know or are given that A is parallel to B and B is parallel to C. It's like the transitive properties. They cancel each other out, and you're left with A is parallel to C, as what we know by the transitive property of parallel lines. You have to make sure that you note that it is the transitive property of parallel lines. Our last theorem. In a plane, if a line is perpendicular to one of two parallel lines, it's perpendicular to the other. So again, we start off. We know our lines are parallel. And we know that we have this transversal that's going to be perpendicular to one line. We'll call this A, B, and C. Now, once we know that information or can deduce that information, the next thing that we can say by this theorem is that B is going to be perpendicular to C. As long as we know we have parallel lines and a line's perpendicular to one of them, it's perpendicular to the other one. And now time for some examples. This is going to be very similar to the stuff that we had in the last section. We're only doing things in reverse. Now we know our parallel lines. And if we know that we have parallel lines, let's look at the angles that we have. We have alternate interior angles. And if lines are parallel, alternate interior angles are congruent to each other. So let's set them equal, and let's solve. Subtract 2x from both sides, and subtract 5 to both sides. We're left with x equals 5. Let's plug that in here. 3 times 5 is 15, plus 5 is a 20-degree angle. Since angle 1 is a vertical angle, we know vertical angles are congruent. Therefore, angle 1 is also 20 degrees. And now we start with a proof. So here we go. We're given a set of parallel lines. FA is congruent to DE and AB is congruent to CD. Let's see what you can do knowing what you know. Here we go. Hopefully you press pause and you're just checking your work. We got our statements and our reasons. FA is parallel to DE. FA is congruent to DE. And AB is congruent to CD. Those are all of our givens. I put in my congruency markings as well. We have congruency here, and we have congruency here. Now we do have some options here, so I want to be careful with what I decide to do. I'm actually going to take my highlighter and I'm going to look at those parallel lines. With parallel lines, you want to go all the way through, so don't just stop where the segment ends, but bring them all the way through. Now let's find a common transversal, a line that definitely passes through both of them, and let's go over that. Again, all the way through. And what can you tell me about this angle here, angle FAB, and this angle here, angle EDC? Well, they're definitely inside my parallel lines, and they're on alternating sides of my transversal. And the one thing I know is if my lines are parallel, alternate interior angles are congruent. So I can say angle FAB is congruent to angle EDC. If lines are parallel, then alternate interior angles are congruent. Let's mark them in here. I'm going to erase some of my stuff that I got. So here we go. We know the congruencies. We now know those angles. And I'm kind of close to having a side angle side for my triangle congruency, but not quite. I only know the AB, and for triangles I need the full AC and the full BD. Well, I see since I have congruencies directly next to and adjacent to an overlapping piece, I can use my addition property. I can say that AC is congruent to BD by addition. Now, I have my three pieces of congruency. It matches up for triangles congruent. Triangle FAC is congruent to triangle EDB by side angle side. Therefore, angle F is congruent to angle E by CPCTC. Hopefully we got that. And here's our last problem for the section. It's called a crook problem. Those of you who've been competing in mathletes, especially at the sophomore level, you might have actually already seen one of these. So here we go. This is actually going to use that parallel line postulate, which kind of seems like a duh postulate, but here's how it's applied. What I have here is I'm looking for the measure of angle 1, and what I know is I have one set of parallel lines, which doesn't actually help me. There's no common transversal. So here's what I'm going to do. I'm going to build a line such that it's parallel to line A and passes through point C. Now, if it's parallel to line A, that means it's also going to be parallel to line B. And now we're going to take one set of lines at a time. We're going to take A with this parallel line, copying down my transversal. I can see this 100-degree angle here and this angle formed in here. They're same side interior angles. And same side interior angles are supplementary, which means this angle formed down here is going to be 80 degrees. Now, let's look at another set. Let's look at line B. And let's look at this parallel line that we drew in. And let's look at this transversal. I see that I have this 40-degree angle that's matching with this angle up here. They're both inside of my parallel lines and on alternate sides of my transversal. And what I know is that alternate interior angles are congruent, making this angle right there 40. Angle 1 was the combination of these two angles. 80 plus 40 is a 120-degree angle. And that's how you do a crook problem. So here's our homework answers. Again, our homework was number 2, 7 through 10, 15, 22 to 23, and 26 to 27. If you have any questions, again, make sure you make note of it, and we'll discuss it tomorrow. Have a good one.